Imagine a world where machines can learn, adapt, and make decisions. This isn't science fiction, it's our reality, thanks to artificial intelligence. Artificial intelligence, or AI, is a game changer, transforming everything from healthcare to education and transportation. Consider the self-driving cars navigating our roads, or the AI-powered systems diagnosing diseases with remarkable precision. Think about the virtual assistants in our homes or the adaptive learning programs customizing education for individual students. These are all manifestations of AI, working silently and efficiently in the backdrop of our daily lives. But where is AI heading? The potential for future growth is astounding. AI is poised to revolutionize industries, reshape economies, and redefine the very way we live. Understanding the basics of AI is therefore not just fascinating, but essential. As we delve deeper into the world of AI, one concept stands out: the neural network. But what exactly is a neural network? In essence, a neural network is a system of algorithms designed to recognize patterns. Much like the human brain, it's composed of layers: the input layer, hidden layers, and the output layer. Each layer is made up of nodes, or neurons, which mimic the neurons in our brain. Now, each of these neurons has a job. They take in information, process it, and pass it along. But here's the fun part. The magic happens in the hidden layers. This is where the neural network learns to understand and interpret the data it's been given. It does this through a process of adjusting weights and biases. Think of weights as the importance assigned to inputs, and biases as the yardstick for triggering a neuron. By tweaking these weights and biases, the network learns to make better and better predictions, much like a child learning to walk. It's a process of trial and error. Creating a neural network is no small feat, but it's a process that follows a series of defined steps. The first step in creating a neural network is defining the architecture or layout of the network. This involves determining the number of layers in neurons, which are akin to the brain's nerve cells. You see, each layer of the network has a specific function. The input layer receives data, while the output layer makes the final prediction. Between these are hidden layers that perform complex computations. The network is then initialized with weights and biases, giving each neuron a starting point in the learning process. Think of these as the knobs and dials that the network will adjust to improve its predictions. Next, we feed data into the network. This data is used to train the network, allowing it to adjust its parameters, those weights and biases we mentioned earlier, based on the errors it makes. This learning process is iterative, with the network continually improving its performance. Once a network is trained, it's ready to be put to work. A trained neural network can be used to make predictions or decisions based on new data. Once a neural network has been trained, it can take in fresh inputs and process them through its intricate web of interconnected neurons. It applies the patterns it's learned, the relationships it's mapped, and the rules it's inferred to generate predictions or make decisions. But how do we know if the network is performing well? We evaluate it using test data sets to determine its accuracy. If the network's performance isn't up to par, we fine-tune it. We adjust the weights and biases, tweaking the network for better accuracy. In real-world applications, these neural networks are all around us. They're in the image recognition technology that tags your photos, the natural language processing that powers your digital assistants, and so much more. As we continue to develop and refine AI technologies, the potential applications for neural networks are virtually limitless.